Hello friends, welcome back in this video. Today our topic of discussion is what are the shift registers. And I will discuss that why do we use shift register if we have the flip-flops to store the bits of data. Okay. And one more point I want to discuss in this video that if we change the order of the bit that we are inputting into the shift register, the output will be changed if we use the order MSB or LSB. I will discuss what is MSB and LSB. So let's start with the definition of shift register. So basically shift register is a group of flip-flops, okay, which are used to store multiple bits of data. So if we can store number of bits in flip-flop, then why do we use shift register? So flip-flops are used to store single bit of data, that is binary, zeros and ones. But in order to store multiple bits of data, we make use of the shift register, right? And to store n number of bits, we can make use of n number of flip-flops. Okay, so I will discuss with the diagram these types of shift register. Okay, so let's start with the first type, that is serial in, serial out. Okay, so this is the serial in, serial out registers. First of all, let me discuss what is MSB and LSB. So if I write here, suppose one one 0 1 0 0 1 1, then uh, let me provide some space between the bits. Okay, so basically MSB stands for most significant bit and LSB stands for least significant bit. So this bit is called most significant bit, right? And this is called least significant bit. Why? Because as you can see, the indexing of the bit start from right hand side to the left hand side. So this bit, that is 1, is at index 0 and this bit is at index 7, right? 0 1 2 3 4 5 6 7. So this bit, that is 1, holds more weightage in this group of bits. Okay, so its weightage or you can see its value in decimal would be 2 to the power 7 and its value in decimal would be 2 to the power 0. Okay, so you can easily compare that 2 to the power 7 is greater than 2 to the power 0. So that is why this leftmost bit is called MSB, most significant bit, and this rightmost bit is called LSB, least significant bit. Okay, because of the indexing or their position in the group of bits. So that is the meaning of MSB and LSB. Now let us discuss the serial in, serial out registers. So this is a diagram of the SISO register. Basically these blocks are nothing but the flip-flops. Okay, this is a flip-flop, and these two are also the flip-flops. Okay, so here we are using 4-bit shift register because we are using 4 flip-flops here, and from here we will input the bits, and from there we will output the bits. Okay, and here we are inputting same clock to all the 4 flip-flops, right? So let's discuss if we use the order LSB to MSB or MSB to LSB. So basically we will input, we are taking example of 1011 here. Okay, this group of bits will be input from this side. So this one stands for MSB and this one stands for LSB. If we take the order of LSB, that is, if we start from inputting from this side 1 1 0 1, then you can see that the position of or the output at Q3, Q2, Q1 and Q0 will be like this. Okay, first of all 1 will be entered. Okay, then here we will get 1. Okay, so here is 1 in 1, then all the rest of the 3 places are empty right now because right now we have inputted only 1. Now let us input this one, then this one will be shifted at Q2 and this one will be come here. Okay, so the position will be like this 1 1. Okay, now let us input 0, then this one will be shifted to Q1, this one will be shifted to Q2 and this 0 will come here. So order will be like this 0 1 1. Okay, and if we input the last bit, then the order will be like this. Okay, so this order is at clock number 1, this is at clock number 2, this is at clock number 3, and this is at clock number 4. Okay, we are applying different number of clocks: first clock, second clock, third clock, and fourth clock. Okay, so the final order is 1011. Now let us try to input the bits in this format. First of all, we will insert this bit, leftmost bit. Okay, 1. So the output will be like this. Obviously, the first step will be similar to this, as you can see here. First bit is 1, then all are empty. Then we will input 0. So what happens? This one will come here at Q2 and 0 will come here. So 0 and then 1. Similarly, then we'll input this one, then 1, 0, 0 and 1. Okay, and the final output will be like this. So as you can see here, by taking different number of or you can say different order, LSB to MSB and MSB to LSB, the output order gets changed. Here we are getting 1011 and here we are getting 1101. Okay, so that is the impact of using the input order. Okay, different input order. So this is about the SISO register. Now let us discuss what is the SIPO register, that is serial in parallel out. So as you can see, from here we will input the number of bits, and from there you will take the output of the bits. Okay, here also we will use the make of 4 flip-flops. Okay, because this is a serial in or in parallel out. And similarly, likewise before, we are applying same clock to all the 4 flip-flops. So here also we will input 1011, right? Let me provide some space. Okay. Now LSB here is this one and MSB here is this one. Okay, first of all let's start from LSB to MSB, that is input from this side, okay. So if we input 1, then Q3 will be 1, right? And if we input this one, then Q2 will be 1 and Q3 will also be 1. Why? Because the one which was previously present at Q3 will not be pushed forward at Q2, because we can take out 1 from here also. Okay, because it is parallel out. So 1 will be present here, this one will be come here, this one will come at Q2, this 0 will come at Q1, and this one will come at Q0. So this is the order of the output. Okay, 1 1 1 1 1 0 1 1 0 1, right? So this is for LSB to MSB. Now let us discuss from MSB to LSB. It is similar to this, but now we will start from this side. Okay, first of all we will enter this one at Q3. So this is Q3. Okay, then we will input Q2, sorry, 0 at Q2, right? Then we will input this one at Q1. Okay, 101, and lastly we will input this bit 1. So final order will be this one, 1011 in case of MSB to LSB, and 1101 in case of LSB to MSB. So here you can also see that the final order has been changed. Okay, by changing the order of the input bits, right? So this is about the SIPO register. Now let us discuss PISO register. So here we are inputting bits from this side, and we are taking output from this side only. Okay, this is not the output, this is the input side. Okay, so 1 will come here, 0 will come here, 1 will come here, and 1 will come here, right? So in this way the inputs are bits are being inputted here in this PISO register. So comment down below and pause for the second to answer this. What will be the final output of this PISO register, right? So pause the video for a while and think about it. What should be the output of this PISO register? Now let us move on to the table of this video. Okay, this is the table. I have created the table for the number of clocks needed for n bit register, basically the shift register. And here I have written the modes. SISO mode, SIPO mode, PISO mode, and PIPO mode, right? So in the SISO mode, you will require n number of clocks on loading and n minus 1 clocks for reading the number of bits. And total you would require n plus n minus 1, that is 2n minus 1 number of clocks. So if you come on to this page, here you can see when the final output is 1011 in case of this, then you can simply take out this bit at the output, right? So here the total number of clocks that we are needed are 4 number of clocks for only loading the bits, that is 1, 2, 3 and 4. Okay, so 4 number of clocks are needed to simply loading the bits, and you will require 3 number of more clocks to read the bits. Why? Because there is no clock needed to read this bit because it is already at the output, but you will require 3 number of more clocks to read these bits 1, 0 and 1. So that's why I said here that the number of clocks needed are n for loading and n minus 1 for reading. So if we, in this case we are using 4-bit register, so n will be 4. So 4 number clocks are needed for loading and 4 minus 1, that is 3 number of clocks are needed for reading. Okay, and similarly for SIPO we will require yeah, how many cycles or how many clocks? N number of clocks for loading. You can see n number of clocks for loading 1, 2, 3, 4 and 0 number of clocks for reading. Why? Because it is already at the output. Okay, you can directly access the bit from this side. You do not need to pass the bit from Q3 to Q2, Q2 to Q1, right? In this way. And similarly for PISO register, one cycle is required to load the bits and n minus 1 cycles or the clocks needed to read the bits. Okay, so this is a PISO register. Okay, so this is about the, yeah, let us also discuss the PIPO register. So it is simply the parallel in and parallel out. Okay, so here simply the output will be this one. Here you will apply 1, here you will apply 2, sorry 0, here we will apply 1 and here 1. Okay, and you can directly access these bits. Okay, 1 will go from there and from here you can access that 1. Okay, so simply the output is uh, 1011, right? So that is all for this video. You can comment down the answer for this PISO register. Already I have given the answer in this slide itself, but I want you to give the answer or the output for this PISO register, right? And I will also give the answer for this PISO register in the comment section. Okay, so that's all for this video. I will come up with the next topic in another video. Till then, thank you for watching this video.